something simple, and if we don't recognize the early warning signs that something is happening, we might end up with a machine destroyed. And so we want to be able to monitor the equipment and understand what's happening right now, but also what happened in the past. And by understanding how these events occur in the past, we can then do predictions and prevent them to occur in the future. Okay. The next slide, Stu. Okay. So machine health starts with sensors and data collections. And when we talk about optimizing machine performance and health, we think the first step in the process is to collect data. And the only way to collect the data is if the machine has sensors on it to read, for instance, temperatures, pressures, flow rates, vibrations, and other important parameters in the equipment that tell us if it's healthy or not. So the second step would be a tool that allows us to store that raw data from the machine so we can then do dashboards or trending of that historical data and get an idea of what happened in the past. And for instance, if we had an outage that happened a week ago, a month, or a year ago, then by using this tool, we can go back into that historian data and try to understand what happened. In this journey, the next step would be to go to the next slide, Stu. Can you go to the next slide, please?
Yeah, it's.
Okay. Yep, that's okay.
Yeah.
So, yeah, thank you. So once we have collected and stored the raw data, the next step should be to be able to optimize our asset scheduling. So we think that still many companies out there most probably still use paper, whiteboards, or spreadsheets to schedule what orders and products are going to run on which production lines or what equipment. However, we know that there is always challenges that disrupt the ability of to optimize, and by using the spreadsheets doesn't allow us for adjusting to actual conditions on the plant floor. So here we need another tool that allows us to not just schedule the production in the first priority, but also allows us to dynamically adjust in real time the allocation of the resources like equipment, might be people, or materials based on the actual conditions of the production. And by having a real-time insight into current production, along with the ability to do things like testing what-if scenarios, like, for instance, moving orders from one production line or piece of equipment to another production line that will result in optimizing the machine utilization. Then I will pass it to you, Stu. The next slide.
Hang on, I was just going to add one thing to your to what you just said, Oscar, and that is that the what you're seeing on this slide is equipment assets over here on the left, and then across the timeline, these are production orders that are going to be run. So each one of these color-coded little blocks is a production order. And then down at the bottom, we can see things like either people resources or materials that are available. And one of the really valuable things that you want to be able to do, important things in my mind, is, what happens if a piece of equipment goes down and we're scheduled right here to run a particular production order, but the equipment's not running. So if we have a tool like this that allows us to say, drag this production order to a different piece of equipment over here, and it will adjust your schedule to show how that's going to be impacted, along with materials that are available. And this information can be updated in real time how would that add value to your ability to really optimally schedule your production out on the plant floor? So a lot, again, back to Oscar's comments, a lot of times we see people that are doing this kind of stuff in spreadsheets, and but it's only as good as the information you have from the actual plant floor equipment and from the people and inventory information and things like that. So we can, if we can provide this real-time insight into those orders and material availability and consumption and things like that, it's extremely valuable. Okay, Oscar, you remind me, am I doing this slide here?
Yes.
I forgot.
Yep.
Oh, we just talked about collecting data using a tool like a time series historian, and then being able to use a scheduling tool to optimize the scheduling of your assets. Now what we want to turn our attention to is taking that raw data that we've got about the assets, say from a historian, and then turning that raw data into data that's got context, data into information. So this is an example of an OEE dashboard that is, again, going to give you real-time insight into your equipment availability and OEE information and things like that. So you now have, we're taking that raw data, maybe we're capturing downtime information on a piece of equipment, and in addition to just knowing that the equipment went down and when it went down, we want to capture maybe other contextual information about that downtime event, things like what caused the downtime event, or and maybe what an operator or maintenance department did to mitigate that downtime event. So the capturing OEE data around the equipment, again, gives you better insight into how that equipment has performed in the past. But we can, if we can provide these kind of live dashboards that show, the availability and performance and quality information that all go into an OEE calculation, and then be able to drill down into, like in this case, we're showing the availability of this asset, and we're drilling down into, and we can see things like the reasons for downtime events, and we can see a timeline of when those events occurred on these different assets and things like that. So if you have that real-time visibility, it's extremely valuable to the operations folks, and the people that are managing those assets, to understand what's causing things like downtime events, and which hopefully then you can take that information and start using it to better operate those assets in the future. But again, this is capturing data that tells you what happened essentially in the past. So kind of the final step in this journey really is, how can we take all of that data that we're capturing, raw data from like the historian, manufacturing context data like we would capture in a MES system, so the OEE data, and maybe even data from other sources, like maybe a maintenance system, so we can start looking at the maintenance history of an asset. But taking all of that data and using analytics to predict and prevent unplanned outages, for example. So in this example, we're showing a simple trend of a variable. In this case, it's an axial position for an asset. And if we've got this alarm set point up here at the top, and as you can see, it looks like everything's going along okay, and then eventually maybe we hit an alarm condition. But in many systems, if we wait until that alarm condition occurs, the equipment may be so far down the path of trending toward a failure that it's too late for us to maybe do anything about it. So what we want to be able to do is use advanced machine learning analytics to look at the data, and not just for single variables like this axial position, but to be able to look at that data across an array of variables, and then build a model using, we actually will ideally we'll take like a year of data to build a model that allows us to understand what normal behavior for the asset looks like across all of these variables. And then if we start seeing abnormal behavior, we want to give early warning indications that the asset might have a problem. So if you look at the way now that what we're showing here on this lower kind of set of trends, we've got maybe an early warning indication with this axial position that was somewhere in this area on this chart. But if we're just looking at the alarm set point, it's not tripping that alarm, right? But we might have, based on this model that we can build using an analytics tool, we might start being able to get these early warning indications that there might be a problem. And what that gives you the ability to do is have time. So you can see we've got this time difference here. So what that gives you the ability to do is have time to maybe schedule an inspection of the equipment and to see if there's some kind of an issue that needs to be fixed. So maybe you have excessive vibration on a pump, and it may be something as simple as the pump has become the bolts holding it to its pad is maybe one or more of the bolts have started coming loose, and it needs to be tightened down. But the bottom line is, we can, using analytics, we can start providing early warning indications that there might be a problem, and it might not be with just this one variable. You might start seeing other indicators across these other variables that, again, give you additional information and context that tell you, hey, there might be a problem, and gives you, again, this time to really go and inspect the equipment, or maybe schedule an outage to do maintenance on the equipment and things like that, instead of waiting until we get to an alarm trip where the equipment is either has already failed or is close to failing. So that's the idea behind using machine learning analytics, is to give you these early warning indications that you might have an issue with either an asset or maybe for a manufacturing process as well. And I forgot, we have our happy guy over here. He's prevented the outage over here from occurring. So that's from the slides we wanted to show. That really is kind of the main thing that we were going to highlight. Let me do something here real quick. I've got to grab my web browser window here. Okay, and I'm just going to show a few examples, but again, using a tool like a historian, a time series historian, we can do things like build live dashboards that show current information about an asset. This happens to be a wind turbine, but it could be some piece of equipment in a manufacturing plant on a production line. And so we can we want to be able to provide this live information, even though these values are updating in kind of what I would call near real time. This data is actually coming from a historian, not from like a SCADA system or something like that. But so we use that historian to capture that raw data, and then the ability to do trending of that information from the historian to give you, again, insight into the behavior of that asset. And, with, trend charts, we might want to be able to show, what is our target value and what are our, upper and lower limits, and be able to zoom in on data and change things like your time scale that you're looking at. I might want to change this from 2 hours to 8 hours, or add tags, additional tags to this trend, and things like that. So, but the bottom line is a trend chart, although it provides you with really powerful information, it's still kind of hard to understand, maybe the relationship between these variables and how they might be impacting each other. Let me move this toolbar here. If again, going from the historian, I don't have anything showing our scheduler software, so the slide we showed was really all I had. But with the manufacturing context, again, if we have an OEE dashboard showing our OEE, we can start saying, 35.8, that's not very good. And we can see the contributing factors to our OEE being low is, quality, performance, and availability. And we can, we want to have tools like this that give you the ability to drill down in and maybe see, what's causing things like downtime events, or maybe performance losses, and things like that. Okay. And then again, the kind of ultimate, I don't have, I'm just going to pull this slide down just like this here, but I don't have a live view of this, but this is actually an example of a dashboard that a customer is using with our analytics software, where they're showing in a trend here on this dashboard an actual value for in this case, they're monitoring a piece of equipment, and they're looking at things like the speed at which they're running the equipment. They're also looking at another variable, but basically the blue line is the actual data. The green line here is the predicted value that says this is an optimal value that you should be running it at. And this particular customer is actually looking at taking that. We're providing the analytic that says, here's what you should be running it at, as kind of an advisory thing to the operator. They're going to take that analytic and they're going to deploy it in a closed loop so that it actually starts controlling the equipment automatically. And so instead of the operators having to look at this trend and go, oh, okay, I should be operating it a little differently than I am, they're going to actually take the operator out of that loop, and they're going to close it and have the analytic do that automatically for them. So that's the kind of thing that you can do when you really kind of go down this journey of optimizing your equipment assets and the utilization out in your plants. So that's pretty much what we had kind of as a high level. I think we'll kind of see if there's, we've got time for some questions. We also, if you have an opportunity, if you could also take a quick survey to give us some feedback on this webinar, we'd appreciate it. But yeah, let's see if there's any questions. Please feel free to unmute yourself and let us know what questions you might have.
We got one question on the chat.
Okay. Yep. Oh, okay. How does C-Sense fit this model? Hi, Leo. So C-Sense would be that machine learning analytic, kind of that it doesn't have to be the final step of the journey, but it was the last step of that journey where we're looking at building an analytic model across multiple variables, maybe for a piece of equipment. And so cSense is our GE Vernova analytic software application that can be used by process engineers and non-data scientist kind of people to understand the behavior of a piece of equipment and to build these analytic models like the one I just showed you from that customer example, where they're providing an advisory analytic and then eventually they're going to do closed loop control on the equipment using the cSense software. So does that kind of help answer what you were asking, Leo?
Yep. Thank you so much.
Mm-hmm. Other questions? Quiet audience. Bob Pickel, how about you? I'm going to call you out since I see your name. Anybody? All right. Well, I think if there are no questions, I guess, first of all, thank you for your time. Hopefully this has been informative, and we are more than happy. Myself, Oscar, and we have a team of what we used to be solution architects. We just our titles got changed to business consultants, but we are the technical subject matter experts in our sales organization, and we're happy to spend more in-depth time with any of you if you're interested to go into more depth on historians or manufacturing solutions, analytics, and so forth, scheduler, and so forth. So thank you for your time today. We really appreciate it, and have a great rest of your day. Aroni, I don't know if you have anything you want to say to close things off.
Yeah, no, you covered everything. Thank you, everybody, for joining. And like we said, you will get this session recorded and sent to you via email after this webinar. Thank you.
Thank you.
Thank you, everybody.